Hi, I'm Kelly and I will be doing a magic trick for you. It's actually a science trick because we know that that's truly how we do magic. So what I have here is a regular balloon, well, slightly irregular, it looks a bit Mickey Mouse shaped, and an ordinary empty water bottle. Although again, as scientists, we know that it's not truly empty because there are air molecules in it, which I will demonstrate for you. Now, watch what happens when I put this regular old balloon, quite hot water. The balloon inflates. Now, that is because of something called molecular kinetic energy. And we know that molecules, even in solid matter, they are constantly vibrating, they're moving, they're just moving in place. Well, what happens is as things get heated or have thermal energy applied to them, those molecules just move faster and faster and faster. And that's what causes a state change from solid to liquid, because as they move faster and faster, they kind of break from their shapes and they go into a liquid state and then a gas state. Well, in the gas state, what happens is they're just vibrating all over. There are more and more collisions, and that's what increases the volume of it. Since this is now contained, the only place for it to go increasing in volume is in here. And you can see now as the balloon is cooling and as the bottle is experiencing cooling, it's no longer inflating. So we can try that again. Every time. Now, and just to prove this is just normal water, it's just heated. This one over here is cold water. It did have some ice in, but it's since melted. So here, actually, let's try down to room temperature water. And you see it deflating quite quickly. Quite quickly. Now that's just the balloon exactly as I got it out of the packaging. Now if I put it in the ice water, notice that the balloon is shriveling up even further. It's like any air that was in there has been sucked inside. And that's because the opposite is happening in thermal expansion. Thermal expansion, it gets bigger and bigger because there are more collisions. Well, as it's cooling, those molecules are less excited now. They're settling down, they're coming back together, and they're taking up less space because instead of being all over the place and just bumping into each other like this, the more they bump into each other and collide, the further apart they go. Well, now they're settled down a bit, they just might be like this, so they're not getting quite the velocity to move further apart. And in fact, the air that was in here is back down in the bottle because it's colder. Now this is room temperature again over here. It'll inflate, but only very slightly, just to normal levels. Back in the hot water. And it's puffing up, but not nearly as much as it was, not as rapidly as it was. And again, that's because now that this water is cooling, it's closer to room temperature. So there's not so much activity. The molecules are not quite as active as they were. And over time, we'll see this effect lessen and lessen because they're just not moving around quite so quickly. So last time, hot water to ice water. I could do this all day. It's fascinating to me. Oh, not quite. Oh, it doesn't quite have the juice now. So this is thermal expansion due to molecular kinetic activity in the presence of heat. Thank you.